We are now recording. All right. Now this is obviously not this year's syllabus. I didn't even know we were going to teach the course until Friday, and I haven't had time to make it. But this is not too far off. It's fall, just 1 year off. Fall 2016, and this will be good for mini term 1. Then I'll give you the mini term 2. Only thing that's changing is office hours between the two. It is Math 238, Applied Differential Equations 1. It's a 3-hour course. Class meeting times, this I'm sure is incorrect. We'll get this corrected. It will be Tuesday, Thursday, 9:30 to 10:45. This room, A255, this building, A building, Bessemer campus, this campus. My name is still the same, Charles Fowler. I've had all of you before. My email address is still cfowler@lawsonstate.edu. Right now, I'm probably close to a week behind in email, so I'll try to catch those up. Phone is still 929-3449, but I'm probably a month behind in phone messages, so when I'm ever going to get those caught up, I'm not sure, but I will try. Now, here's where the changes come. So I'll get this corrected and get it out there for you. But my Monday, Wednesday office hours now will be 11:15 until 12:15. Monday, Wednesday. Then 2 to 5:15, Monday, Wednesday. Okay. What's that?
Until second minute.
Okay, no, that'll be throughout the term. Throughout the term. It's Tuesday, Thursday that change.
Oh, I thought you said.
Okay. Okay, so it'll be 11:15 to 12:15, just a minor change there, and then 2 o'clock until 5:15 will be the next thing. Okay, Tuesday, Thursday, now this has changed completely, will now be 12:30 until 5, for the first mini term, 12:30 to 5:15, and for the second mini term, it will be 12:30 until 3:15. Oh, that's when my second mini term class begins. Those are all on Bessemer, and my office on Bessemer is in 265. All y'all know where that is, right? Now, the guy who was in here, he doesn't know where that office is, so he's going to have to learn where that is if he needs it. On Friday, I'll be on Birmingham campus, 7:45 to 11:45. The academic building, room B122. If any of you need to know where that is, I'll explain it to you individually. Okay? Now, let me tell you this. This Friday, if my understanding was correct, I've been assigned to a screening committee for a new math position. And from what I understood from the chair, we will be screening probably, I don't know what time he's going to get there on Friday, so I may be in my office for a little bit, but at some point we'll be down in human resources screening probably for the rest of the day. So the odds are I'll not be on campus much in my office much on Friday. I'll be there at 7:45. I doubt if they'll start screening that early, but they may start at 8 or 8:30 or 9 or something like that. But whenever they start, I probably won't be back in the office until close to 11:45. The screening is pretty involved. And then after that, we'll probably do interviews the next Friday, okay? Now, here's something else. I don't want to go into gory detail, but I think all of you have been in my class before and you've heard it. I have a mild form of leukemia, so I've got and I've been on one treatment that for several years now that just have a treatment once a quarter. It's not doing as effectively as it used to, and the doctor wants to change to a different treatment, which has a strange protocol. Once I start it, it'll be once a week for 8 weeks. So that'll be basically 2 months. Okay, and I'll have them on Friday, so I don't want to miss any classes. And then once a month for 4 months, and then once a quarter after that. So for a while, it's going to be different. Now, I'm going to request that the treatments be Friday afternoons, but I always request that, and they still sometimes assign me mornings. So on those mornings, I will not be available those Fridays. But I'll let you know, because I'll know from 1 week to the next when the next treatment will be. So I'll let you know if and when I'll be available on Fridays. Okay? Sorry about that. All right, let's see what this will do. This is the course descriptor. Okay? Now, I didn't write this. No one here at the college wrote it. It's done by a committee of 2-year college and 4-year college and university personnel. They said if we meet this requirement, they will give you credit when you transfer. An introduction to numerical methods, qualitative behavior of first-order differential equations, techniques for solving separable and linear equations analytically, and applications to various models, populations, motion, chemical mixtures, that kind of stuff. Techniques for solving higher-ordered linear. This glare is terrible on the board. I'm having trouble reading it. Maybe I should read it from here, but it's so small. Okay. Techniques for solving higher-order linear differential equations with constant coefficients. General theory, undetermined coefficients, reduction of order, and the method of variation of parameters. Several different techniques there, with emphasis on interpreting the behavior of the solutions and applications to physical models whose governing equations are of higher order. The Laplace transform as a tool for solution of initial value problems whose inhomogeneous terms are discontinuous. Whoever wrote this thing, I don't know. That is one of the most confusing course descriptions I've ever seen. Okay? I've still got my calculus book out and open. So move that aside and get my equation book. Okay? Let me give you a lot better, more concise course description than that. Okay? Now, I see one book, and that's all, right? Okay. Basically, I would say read chapter 1. It's 3 little sections, okay? I will go over some of that, but I'm not necessarily going to teach it. And by the way, this book does not, as far as I know, I don't think anything's changed since the last time I taught it. I don't believe they have any PowerPoint presentation materials at all. Okay? No. Not that I can see. And by the way, yours is just like this, right? Without the blue on the edge. Yeah. Okay. That's it. All right. So basically, we do first order differential equations. Okay? That's chapter 2. Okay? Now, we may come back and do a little bit of modeling with that, but I don't, if I am reading that right, I really don't see modeling on here anywhere. So I'm skipping chapter 3 for now. Okay? Y'all see modeling in that course description? I think I looked for it and didn't see it. So we're skipping chapter 3 and going to chapter 4. Higher order differential equation. Right there. Okay?
Application to various models.
Okay. Yeah, okay. But that's, to me, not quite the same as modeling. So we'll skip to chapter 4. Chapter 5 is again modeling. And chapter 6 is series solutions to linear equations. And again, that's a pretty hard thing to read, but I don't see series solutions on there either. Okay? So we skip chapter 5 and 6. Now I do see Laplace transform here. So we'll do chapter 7. Okay? And then systems of linear first-order differential equations. And I think I looked through this and couldn't find systems of linear differential equations either. So we'll skip chapter 8 and go to chapter 9, which is numerical solutions for ordinary differential equations. And that's the very first thing there, introduction to numerical methods. Okay? Why they listed that first, when most books that I've seen, that's one of the last things they do. Okay? So, what our goal will be chapters 2, 4, 7, and 9. Okay? And if we get all those covered, and here's why I say that. Chapter 2 is not bad, but it's going to take a little while. Chapter 4 is 10 sections. Now, whether we cover all 10 or not, I don't know, but there's a lot in there. And you notice all this stuff in here. You have homogeneous, inhomogeneous. You have reduction of order that was in there. You have constant coefficients, undetermined coefficients. See, here's constant coefficient, and here's undetermined coefficients. And they don't mention variation of parameters. Yes, yeah, they do right there, variation of parameters. Now, Cauchy-Euler equation and Green's function, we may skip those because I don't see that mentioned here. So we may skip some of that, but that is one huge chapter. And by the way, the whole chapter is 76 pages. I've seen some books that long. Okay, so Old Men in the Sea. No, I'm just kidding. Okay, chapter 7 is 52 pages, so we probably won't do all of that either. But we'll introduce the Laplace transform, and we'll do some numerical solutions. Okay, how much I don't know, but these are some pretty hefty chapters. Chapter 2 that I mentioned, which I said wasn't too bad, that's 48 pages. So these are pretty significant chapters. All right. So that condenses to those 4 chapters pretty much. I think we do a good job of covering that. Prerequisites, Math 227, we're now counting that as a co-requisite. Okay? So several of you, I think 4 of the 5 people, you've already had 227, so only one person has actually had it, so you'll be taking it. Okay. Textbook, and that's what I was just holding up. Required text. Ooh, goodness, that's the wrong one. Okay, here it is. First course in differential equations with modeling applications. Oh, where is it? 10th edition. And this is by Dennis G. Zill. Okay, it's a Thompson Brooks Cole Cengage 2012 text. You probably would be very good to have a graphing calculator. It's not required, but I think it might help you see how these things unfold a little bit better. Paper, graph paper, pencils. If you want to use ink, that's up to you. That's the requirements for the course. Okay? And here's this paragraph on Blackboard, and y'all have all heard this, haven't you? Okay. It's allowed. They don't let us change it. So many things are out of pocket. Use Blackboard. It's helpful. Okay, we'll go with that. Okay. Course student learning outcomes. These are new for you, I know, so let me get this done. Whoa! All right, we'll leave it there. Students will find solutions of first-order differential equations, including separable equations and linear first-order equations and applications with various models. So you see there's the models in there in that sense. That, by the way, is Chapter 2. Okay? Number 2, students will solve linear equations of higher order, including equations with constant coefficients and undetermined coefficients. That's a very quick snapshot of what we'll do in Chapter 4. Huge chapter, higher order differential equations. Outcome number 3, students will use Laplace transform methods to solve initial value problems with discontinuous functions. That's Chapter 7. Okay? And then students will use numerical methods to approximate solutions to systems. That's Chapter 9. Okay? And students will research and write on a topic in differential equations. Surprise, surprise. Okay? The guy who's here to hear that isn't. Okay? Too bad. Sorry, you'll hear it later. Be sure to remind me to alert him to that fact. Yuck. All right, the core competencies, and these go directly, like I just said. Chapter 2 is the first student learning outcome. We'll have a test at the end of that. Now, let me ask this question. Y'all have a preference for in-class or a take-home test? Take-home. Wow, I'm surprised. Shocked beyond belief. Okay, so we will have take-home tests, so we'll do a first-order differential equation, then your assessment will be a test on that. Chapter 4, linear equations of higher order, a test on that. Laplace transform methods, a test on that. Numerical methods, a test on that. Your writing competency will be your research paper, and I probably will change this. Your overall competency will probably be your Chapter 9 test, okay? I doubt if we'll do a comprehensive final exam. My guess is we'll have a test there. But guess what? This numerical methods going to cover all and more of this, okay? So that, in a sense, will almost be somewhat comprehensive.
Okay,
Yeah.
let me ask a question.
Surely.
For those of us who are taking this as a co-requisite to calculus,
Yeah.
is there anything we should probably breeze over in the calculus book before we really get into this class?
I don't think so. I think that, yeah, there is something. And it's not in Cal 3. Go back to Chapter 9 in your calculus book. Differential equation. Good place to start. Do a little review of that. That will be most beneficial in getting started here. Actually, you'll use a little bit of that here too, but mostly up there. Okay? So that's a good question, but it's not Cal 3. It was in the middle of Cal 2. Okay. But we didn't do it in Cal 2 because it's a different course. Okay, I think you understand this. Y'all have all been in my class before. Research paper is required. It will count as a test grade. That cannot be dropped. That test will be given after each unit, and these will be chapters in this one. The last class had chapters down. I needed to put units. This one has units. I could put chapters. The lowest unit test score may be dropped. The comprehensive, I'm not even on time. The final exam may not be dropped and will count as either 1 or 2 test scores, depending on what will help you the most. Each assessment is graded on a 100-point scale, and you know the breakdown there. So let's look at attendance. Oh, no, don't do that. Okay. And I think you've heard this one before in every class you've been in of mine, right? Please try to be here. If you can't be here, you're probably not going to get the material as well. And again, I'm using a new lecture capture program here. I don't think it's as good as Tegrity was. What I haven't been able to determine is whether you can pick out just the portion of the lecture to look at.
You probably just got scrolled.
Yeah, so that's a little bit of a pain in the neck or some other body part. So, but anyway, try to be here. The Screencast-O-Matic will do a decent job of catching up anything you missed, but really it's better as a review than as new material. Okay. All right, makeup work with take-home tests. That sort of doesn't make a lot of sense, but try to get your things turned in within a week if possible. A lot of these tests you probably will take more than a week. That's fine with me, but I just would rather you not be hanging on to test 3 when I've already given test 4, or vice versa. Test 2 when I've already given test 3. Try to get them in before we get to the next test. The sooner you can, the better, because guess what? All you're doing is keeping your classmates from getting feedback from the previous test, because I can't return the papers to the others until I've gotten them all in from everybody. All right, any questions on that? Lateness, I will, well, since we're going to move to Tuesday, Thursday at 9:30, I will be in here already Tuesday, Thursday, 8 to 9:15, so the class will probably start right at 9:30. Try to be here. I know some of you may be coming from Birmingham campus or whatever. If so, get here as soon as you can. I think you've all heard the statement on discrimination and harassment, right? We don't tolerate it. It is not tolerated, will not be tolerated, it's never tolerated. You get the idea? We don't tolerate it, okay? So if you see or sense that anyone, not just yourself, certainly yourself, but anyone else might be being harassed or bullied or discriminated against, let somebody know right away. We will deal with it, and we'll try to deal with it fairly, but quickly and thoroughly, okay? Any questions on that? Okay? Americans with Disabilities. Same type thing here, though it's a completely different subject, but it's federal law. I mean, and it's not just because of federal law, it's just what's doing what's right. As you know, I'm hard of hearing, so I'm somewhat sensitive to this. Differential equations or... Say again? No, this is 255. That's in 256. Go down the half flight of stairs, last classroom on the right, but it's next to the last door on the right. Yeah. That's a new one. Okay. Yeah.
That is a new one.
Yeah. Not quite the same as differential equations. Right. Okay. All right. So we try to accommodate every student who comes here. If you need something special, please get the information. Now, someone help me out here. Our ADA representative on this campus, I know it's Dr. Renee Herman, but hasn't, whoa, yes, this is old. I think Miss Falana Suggs replaced Miss Williams, but didn't I hear that Miss Suggs had moved on? Oh, does anyone know? I don't know. I'll have to find out. I know it's not Janice Williams anymore. It was Miss Suggs, and it may have even changed from there.
Dr. Herndon.
Yeah. If you are an ADA student, it's your obligation to bring the materials. We can't assume that you have a problem. Otherwise, we may be discriminating on you if you didn't have the problem, okay? We made that assumption. So you have to do that. But if you feel like you're not given a good shake, we will certainly help you write us up with the grievance procedure. We want you to be have every opportunity you can. The reason we're here is to make sure you have an opportunity to learn material and however best to do that. And we try to do that. Obviously, this course calendar is wrong, but it's not too bad because it was a fall term. I'll get these dates and years changed and adjusted, and I'll get that done. And I think that's all. Student acknowledgement form. Once I get the,
Get our air signature.
yeah. Once I get this syllabus changed and updated, then I'll put it out there. I'll let you know. It'll be on Blackboard, and you can either print this page and sign it and turn it in, or you can extract the page and email it to me. Either one. Okay. Any questions on the syllabus? Okay. New book, new material. I'll save some of my stories for later. Okay. All right. I'll go on and get out of this. Yes, sir. Which class? Okay, Cal 3 actually starts, in about 15 minutes. Thanks. What's that?
I said he's in here. I know that.
Yeah. He was in my summer class, I think, wasn't he? Or was it last spring?
I think it was spring.
Spring, okay, that's it. Okay.
I think it was in physics.
Yeah. Yeah, okay, that's right. When you get old, things run together. Okay. I'll go on and I think I'm through with that for now. All right, research paper. All of you have seen this before. Do you have anything you want me to go over anew in this? Any questions? Okay. Because I know you've all heard it before, probably ad nauseum, because this could be the Humpty class for some of you. Here is the only thing that will be changed. I can't put it on Blackboard yet because of this. I'm going to start from the back end and work up. If you turn in your paper in the month of December, you just get your score. If you turn it in the month of November, you get your score plus 1 bonus points added in the month of November. In October, 2 bonus points added. September, 3 bonus points added. If you turn it in this month, we don't have much August here, but if you turn it in the month of August, 4 bonus points. Okay? So get started early and often. Okay? Because guess what? This is the time you have the most time to work on this. And if you just glance through the things we just looked at, if you chose people, let me just look at some of the titles here. Uh, 4.7, Cauchy-Euler equation. There's 2 names, Cauchy and Euler, this equation, and there's tons of things like this. That's 3 potential papers, no, 4. Who was Cauchy? Who was Euler? How did they develop this equation? Who developed what part, and how did they combine together? That could be yet another one. How are these equations applied? Where are we using these? Green's function. Who was Green? Okay, how did he develop this? How are they used? And this, by the way, initial value boundary value problem, there, that's where you run into that as well. So every time you see something like that, and even in chapters we're not doing, you certainly could pull anything out of that. Laplace transform. Who was Laplace? Okay, how did he come up with these transforms? How are they used? Let me get some of your majors. I know your math. Electrical engineering. Civil. Mechanical.
3 engineers in that?
Yeah, right. And I don't know who the third one is, a 4th guy. But I'm pretty well certain electrical engineering, Laplace transforms, I think, are used a lot. I think I'm right on that. I remember there was one engineering field that really uses a lot of Laplace, and I believe it's electrical. Okay? And maybe the other 2 as well. Who knows what they do with that. Okay. Then when you get to, here's another one. This is interesting. The Dirac delta function. Okay? Who is Dirac? How did he come up with this? How is it used? We probably won't get into that this term, but it's here in the book. And then chapter 9, Euler methods. Okay, we had Euler before. What are the Euler methods? Runge-Kutta methods. Runge-Kutta methods. Who was Runge? Who was Kutta? So that's just in the names. And by the way, in the appendices, which you probably won't get to, gamma functions are mentioned, which are a pretty powerful tool in certain areas. So you might want to take a look at those too. And then there's all the possible topics like applications, things that your field would be using this stuff for. So there's tons of things out there. Okay. And remember, you could go to your computer application. If there's something we're doing and it's really confusing to you, that type of thing, if you go out on the internet and find something that really makes it clearer, that could be your paper topic. And I'd really like to have those so I could put them in for the next time I teach this class. Even this time, put those sources, links out there so other people can take advantage of those too. Okay, I don't know that I have any outside links so far for this course. So any that you find for me, let me know. Whether you write a paper on them or not. If you feel like they're helpful, let me know.
That's interesting.
What's that?
That's interesting.
Yeah. Okay. Good deal. Any questions then on this? Okay. Let's see. I'm not going to close that. I'm going to minimize it. that in my next class. All right, what to do next? We have 7 minutes. Okay. You're here for Cal 3. Right, okay. Yeah. This is amazing. I begin my day with his wife and end my day with him. I think the beginning's much better, don't you? No, I didn't say that, did I? All right. All right. I could get started on safety a little bit if y'all want to do that, or should we save that for tomorrow? Okay. We'll end it now, and because the other guy's not here, I thought he was coming back. But we'll meet tomorrow morning, 9:30, and then for those who are interested, linear algebra will be at 11.
So, if we add that, are we have to go back to the stars and all that?
And what?
That'll be a big ordeal, I think.
What?
To sign up for another class.
Right. It's up to you, yeah. It's just a drop ad. Now, it'll probably say there's conflicts, because I think that was 2 o'clock, wasn't it, originally? So, obviously, we're not meeting at 2 because there's conflicts in. So, we'll have to...
I guess tomorrow...
I guess since everybody's been removed from the class, I can change the times on that one. This one is going to be a little tougher because everybody's in here already, but the times are going to change. So I'll put that as a remark on that. It's been moved to Tuesday, Thursday, 9:30. All right, it's going to be an interesting term. All my office hours are rapidly disappearing, but we'll manage.
Up to 4 math classes.
What's that?
Up to 4 math classes.
Yeah, for you. I'm teaching 4 on Mondays. Wednesdays, I think. I've got 100, Cal 2, Cal 3. No, I guess I'm just 3, and then Tuesday, Thursday,
At least 2.
pre-calculus, and these 2. So 3 then, and then I'll add a physical science second mini term. 7 classes. Good deal. All right, hope you can make it tomorrow, but if not, I'll be recording. Hopefully we can get these so they go out there well. Okay. Good deal. So now it's time for Cal 3.
Yeah,
227 syllabus right there. Okay. All right. Oh, I need to end this one, don't I?